Greetings. This session today is on query optimization statistics, as the title says, the driving force behind good performance. First of all, about me, my name is Vern Rabe. I'm in Portland, Oregon area, and a couple of things I always like to point out on this slide, the only things I like to point out, is that I've been working with SQL Server since version 4.21a, which goes way back, and also that my first PC had a 10 megabyte hard drive, and that just kind of points out how old I am. So today I'm going to start out by talking about what the optimizer is, because it's important to understand the optimizer in order to understand why statistics are so important. And the optimizer is an amazing piece of software within SQL Server. It's often considered the most important section of software. And it determines how to execute a query. So you submit a query like select these columns from this table, join this other table, and on clause. You submit that to the optimizer, and it has to figure out how to execute it. And there are many, many ways to execute even a relatively simple query. And so it has to determine a good way. You might often hear the expression that it's going to find the best way. Not true. It finds the first method to execute it that is good enough. And when it executes that, or when it determines that, it has to go through many algorithms until it finds the first one that's good enough. And those many algorithms, there can be many, many, many. By the way, every time I have a red dot on the slide, that's a note to me that I have a demo. So if you see me go past a red dot without doing a demo, yell at me. So in this join example, all I'm going to do is show you a join and look at the execution plan that the optimizer came up with the sole purpose of pointing out with a very simple join how complex, how many different possibilities the optimizer has to consider. And I'm using AdventureWorks 2014. And the query that I'm going to execute here is simply a join with a person.person table and the person.person phone, and I'm looking for any person whose phone number starts with 340. So there's a single predicate, that's the where clause down at the bottom, a single join predicate, and two table join. Really quite simple. When I execute this and take a look at the plan, and I need to turn on actual execution plan, and then we'll execute it. A couple of things to note here. First of all, this object, this operator, is an index seek. It could have done an index scan or a table scan or a heap scan if there wasn't a clustered index. This table here, it also did an index seek. It maybe had to analyze several indexes to see which one was best. In this case, it did a nested loop. There are three different ways it can join tables. It can do a nested loop, a hash match, or a merge join. In this case, it said a nested loop was the best choice. And a thing to point out here, you might often see in blogs where people state, I've got a query and it's using a nested loop, I've got to fix it. In other words, implying that nested loops are bad. Nested loops have their place. All three of those operators have their place. Nested loop is the best operator for this case. The reason that nested loops have a bad rap is because if it chose a nested loop when it should have been, for instance, a hash match, the performance can be really bad. Whereas if it chooses a hash match instead of a nested loop, it can be kind of bad. So nested loop gets a bad rap, but it has its place. So the point here is just simply that there's a lot of options for the optimizer to go through and determine how to execute the query. The order of tables. I didn't mention that. It could have chosen one table to be the outer in the nested loop versus the other. That's another option it considers. When it takes a look at a query and tries to come up with a plan how to execute it, the cardinality is one of the most important things that it has to look at to help it determine. The cardinality is the number of rows it expects out of an operator within the plan. Sometimes that operator is nothing but a table or an index, but the cardinality is a major factor. And the cardinality is determined from statistics. Herein lies the importance of statistics. The optimizer looks at the statistics, from that comes up with an estimate I think I'm going to get 420,000 rows out of this table. Based on that, it's going to decide among, how to join, what order to do them in, all kinds of things. That's a major, major factor in how it decides how to execute a query. One thing to note is that as of SQL Server 2014, the cardinality estimator, which is a small piece of code, was rewritten in that version. Long ago, Microsoft got merged with or worked with Sybase. Sybase had written the software for the database management system. And in the end, Microsoft pretty much took over that software. And that cardinality estimator is the same one that's been in place until version 2014. And I'll show you some of the examples of how it's different as of 2014. But it's been the same one since way back then, before 4.21a. So exactly what are statistics? And this is a key phrase right here, a couple of important terms here. Estimated summary information of the distribution of values in one or more columns. Key thing is estimated. These are not precise values, they're estimated, and therein lies some risk. It's summary information. It's not the detail of everything in that column. It's just some of the information, helping the optimizer determine how the data is distributed within that column. If you had 1 million rows in a table, and the statistics would give you a summary of, oh, we've got so many in this range, so many in this range, that kind of summary information. Where are statistics created? Every index that you create will have a statistic object associated with that index, unavoidable. By default, any column that is referenced in a predicate will have a statistic object on it. A predicate is one of those lines in your query that could be where this column equals that column, or an on clause, on this column is equal to that column. Any one of those rows that can return true, false, or unknown. That's a predicate. So if you submit a query and say where this column is greater than 5, by default, and I'll get to the default a little bit later, by default, if there aren't statistics on that column, the optimizer will say, wait a second, I'd like to have statistics on this. Don't determine the plan yet. Go and create the statistics on it. Then I can get cardinality from that column. Now I'm going to figure out how I want to execute the query. And you can create your own statistics. You can explicitly say, I want statistics on this column, or I want statistics on these two columns together, or I want filtered statistics. I want statistics on this column other than the null values. Exclude those. It takes up too much of my space. Within the statistics, there's 3 sections: header, density vector, and histogram. I'll show them to you, but the histogram is the one that I'll be covering primarily. We'll just briefly go over the header and the density vector. So a few things. How do I read statistics? And this is where we'll get in. We'll see the header and the density vector. And there's several ways to read it. One way is with SQL Server Management Studio. And here's my dot, so I've got a demo. And when I go into Management Studio, over on the left-hand side is the Object Explorer. And if I open up a database, and again, I'm using AdventureWorks 2014, and I'll go to a table, and I use a sales order detail table a lot. And you'll notice there that underneath that table, I have a subfolder called Statistics, and when I expand that, it shows me all of the statistics on that table. So a few notes on the names. Notice the bottom 3, AK something, IX something, and PK something. You might guess accurately that those are ones that created because there was an index created on that column. A primary key that was created, and an index was created with that primary key, alternate key. The other 2, the top 2, underscore WA. Anybody have a guess what the WA stands for? Yes?
It is the acronym for Washington.
Yep.
Abbreviation, excuse me. Abbreviation.
Microsoft is proud of the state that they're in, the state of Washington. Term sys, and then the next set of characters, 0000, a whole bunch of zeros, and a 6 and a B in our 2 examples. That is the hex position of the column. So that is the 4th column and the 11th column physically within the table. And the last one is identifies the table itself. There's an algorithm that it takes the ID of the table and munges it and comes up with this number. So within a table, those last characters will always be the same. And if I were to double click one of these, so let's take number 4. So the fourth column in is, in this case, a special offer ID, so we can see which column it's on. And I can look at the details. Here we see the 3 sections of the statistics. The top section is the header information. That's there. Then we have the density vector underneath it. And underneath that is the histogram. And we don't see only see part of it. And I don't know how well this will be viewable without a zoom, but if I scroll across, you can see there's additional information on all of them. I will show in a different screen what the histogram and what the rest of that information is. So this is just to show you that you can get it from the Management Studio. You can also look at it with SP Help Stats, which is a deprecated, as I have commented there, stored procedure, which means that it will disappear in an upcoming version of SQL Server, so don't use it. And by the way, just a side note here, because it always reminds me, SP underscore, don't start your stored procedures with SP underscore. Although they work fine, they may work fine, that's a special prefix. And if there is a stored procedure SP with the same name in the master database, then that will get executed, not yours. So do not prefix your stored procedure with the SP underscore. My favorite way, and I think a lot of people's favorite way to look at statistics, is with a dbcc command of show statistics. And there are 3 options that I noted there with stats header, with density vector, and with histogram. Instead of returning all 3 of the sections of a statistic object, you can say, I only want to return one of those 3. So here we're going to look at, turn off that. The first one is simply going to look at the statistics of the PK, the statistics objects associated with the primary key. So the arguments for that, for calling dbcc show statistics, are the name of the table, including the schema, and then the name of the statistic object. So when I execute this, and I highlighted incorrectly, when I execute this, I'll do it again. When I execute this, we'll see all 3 sections of the histogram. Wow. All 3 sections of the statistics. A couple of things to note. Up here in the header section, the updated is a key thing to note. Right there is updated. That is the last time the statistics were updated. So let me take a side thing here. So let's say that you have a query, you submit a query that has a predicate that references a column, and the statistics object for that column doesn't exist yet. By default, it'll get created, and there it sits. It doesn't get updated. You modify that table, it doesn't get updated, because if it updated with every change to the table, the cost wouldn't be sufficient benefit. The cost would be too high. So what happens is that periodically it will get updated. And there's some algorithms that we'll get to shortly of when a statistic object will get automatically updated. This column in the header tells us the last time that statistic object was updated or created. The last time it had current data. Also noted here are the number of rows and the rows sampled. That's the number of rows in the table and the number of rows that were sampled in the process of creating this data within the statistic. Not all data, not all rows in the table are queried necessarily when creating or updating a statistic. The more rows you sample, the more accurate it's going to be, the longer it's going to take. There's always a trade-off. In this case, it was a full. Every single row was sampled. steps. The histogram of a statistic object can have up to 200 steps. Remember I said it's a distribution of data. We could have millions of rows in a table. We're not going to have millions of steps. We're only going to have up to 200. And we'll see what they look like down in the histogram. The next section, the density vector. I knew I couldn't find it. The density vector is very useful to the optimizer when there's more than one column, because it gives you the density of the first column and it gives you the density of the two columns. That's a uniqueness. How many unique values are there? The last section is the histogram. To me, that's the most important. So let's look into this a little bit more detail. First column is the range high key. And that's the definition of the steps, up to 200 steps. That tells you, okay, this is the lowest value, and then go higher and higher, and then the highest value that it has recorded. The column of range rows says how many rows are in the table exactly, or between this, less than this key value and greater than the previous one. So let's take an example here in the middle someplace. Let's take this guy. So that 370 says that there's approximately, these are always approximate, 370 rows greater than this value, but less than the 44,570, in between those two values. Looking again at still at the same row, the equal rows, that says that there are approximately 32 rows in the table exactly equal to that value. So you have how many rows expected equal, how many rows expected equal to the previous one, and how many rows are in between. And again, they're all estimates. The next column is distinct rows. Within that section in between, greater than the previous and less than this one, how many distinct values are there? So if we had a range row of 32 and distinct range rows of 32, that would mean that every one was unique, that there weren't any duplicates whatsoever. This last column is nothing more than the math of taking the range rows and dividing by the distinct rows. So if you think about that, if the query is submitted that says, give me everything where it's equal to 44540. Okay, that's a value in between those two. So the optimizer would say, I'm going to guess that there's 11.93 rows matching that value that you just submitted. Because for every value that exists between those two, that's the average number that you'll find. So the important, well, they're all important, but the 200 steps, the range rows, and the equal rows, those are very important to the optimizer. Okay, I didn't show one last. Let me go back. I skipped one. So this is the same query, only I'm adding a with histogram option at the end. So this is nothing more than a convenience. We'll get the same thing we had before, only we will only get the histogram. So I almost always use that, but use whatever you want. Okay, SP Autostats. I had mentioned that by default, if you submit a query where a predicate references a column for which a statistic object doesn't exist, by default, the statistics will get created. So the SP Autostats, I may have stated, I think I stated that once statistics are created, they're not updated with every update to the table. There has to be a certain amount of changes made before it'll get updated, otherwise it's just not worth it. You can turn off that behavior so that once statistics are created, they're not updated. This stored procedure shows you whether or not a column is configured to be automatically updated. It also allows you to turn on or off that automatic updating.
Can I ask, are they
Yes.
automatically set up to automatically update by default?
By default, it's turned on.
Okay, thanks.
Yes. So when I execute this, And I'm specifying simply the sales table or sales schema, sales order detail table. So it's going to return all of the statistics objects in that table and tell me whether or not the automatic updating is turned on or off. And when I execute that, I get the 5 statistics, and in this case, they're all turned on. And also note that it also tells us the last time they were updated. And yes, and one of them, the last one there, was just updated just before I started this session. That's because I queried it very specifically to create that as a demo. In addition, in this case, I am going to specify a single statistic object, and I'm going to explicitly turn it off. And then I'm going to follow by doing that same query again, just reading the results of that. And you'll see that now, the one that I specified has been turned off. I'll get to a little bit later why you would want to do that. There are not super rare, but somewhat rare occasions when you may want to say, no, I don't want you to update the statistics automatically. I want to manage it. And well, let me put that back like it was. Just turning everything back on again. There are also 2 system views, even though they look like tables, sysstats and sysstats columns. And if you want to do your own management of statistics, you might want to get into these 2 views. And as the name implies, the sysstats returns 1 row per statistic, and sysstats columns returns 1 row per column within a statistic. So if you have a primary key with 2 columns, then the stats columns will return 2 rows for that one. And lastly is a dynamic management view. How many of you use dynamic management views? No, hardly anybody. There's hundreds of dynamic management views. They are awesome. They give you all kinds of insight into the internal workings. And this particular one, DB Stats Properties, shows you some information that you can't get too many other places. And here I'm going to simply query, wrong one. I'm going to query the DB Stats Properties, and I'm going to specify the table name. The object ID of the table name is the first passed-in parameter, and the second one is the ID of the stats object within that table. And in this case, the number 1 refers to the primary key. So when I execute this, one of the most, well, several things that we see here. First of all, we have an object ID. We have the same last updated date. That can be very important. Rows sampled. We've seen these before. And here is the important one, modification counter. Remember that I mentioned that they're not updated automatically with every change to the table. There has to be some threshold that is met. This is where it keeps track of the count of changes approaching that threshold. So if you look in here and you say, oh, look, I have 0 changes, then updating the statistics on that, or updating that statistics will do nothing because it won't change anything, because nothing has changed in the table since it was last updated. Whereas if you see 4,000 in here, you might think, well, maybe I should manually update these. They're getting stale. There's been a bunch of rows updated. So that's a very valuable table, view, dynamic management view. So how should statistics be maintained? First of all, who knows of Ola Hallegren? If you're a DBA, you know him. He has created several scripts. They've been around for years. He has scripts for maintaining all kinds of DBA activities, widely recognized as some of the most valuable free scripts, and he has some scripts to maintain statistic objects. That's a great starting place. It won't cover everything, but it'll cover a lot of cases. This is an option, the auto update statistics, and this option turned on or off will allow within the database, just as we talked about, whether or not the statistics will get updated. An important thing here is the async. Remember I mentioned that when the statistics reach a threshold, maybe I didn't mention this, and the optimizer says, here's a query, go look at the statistics. Oh, wait a second, they're stale. They're flagged that they need to be updated. The optimizer says, stop, update those statistics, then it's going to execute or come up with a plan for the query. The async option says, no, I don't want to stop the plan generation when you reach the threshold. When you reach the flag of the threshold, just, okay, go ahead and come up with a plan based on the stale data. And then when I'm all done, when the SQL Server has a moment of spare time, it's going to update those statistics. So it won't interfere with that one statement. By default, async is not turned on. There are cases when it's a better thing to do with having it turned on. Generally speaking, if you're doing large quantities of rows, like a batch import, where you're doing 1,000 rows at a time, 10,000 rows at a time, you don't want async on. Because if you're out of sync, you may be way out of sync, and you want the latest statistics. If you're updating 1 or 2 rows at a time, when it hits that threshold, gee, 2 statements ago, it was only 1 query or 1 row under the threshold. Now it's 1 row over the threshold. Hardly any difference. That's a case for async. So by default, async is not turned on, but you may look at your situation, consider whether you want to turn it on. What is that threshold? Prior to 2014, for larger tables, for smaller tables, we don't even care. For larger tables, more than 500 rows, there had to be 20% of the rows in the table change plus an additional 500 rows. So if you have a table with 10 million rows in it, 20% is 2 million rows and plus 500. So 2,500,000 rows have to change before that statistic object is considered stale and it's going to get automatically updated. That's a lot of rows. And because of that, one of the most significant changes when the cardinality estimator was rewritten was to make it more aggressive. Microsoft has not published what that aggressive algorithm is, but for larger tables, they're much quicker to update the statistics because that linear on large tables just doesn't work very well. Auto-create statistics. Again, I mentioned to you that by default, if a column is referenced in a predicate and there's no statistics for it, they will get created. You can turn off that behavior. It's a pretty rare case that you want to turn it off because the statistics objects are tiny. They don't take much work to maintain them, and they're very valuable. Okay, here's auto-create statistics. Here's a query that I have, and this simply is a query against the stats and stats columns table to show you that within the sales order detail, I only have two columns that have automatically created statistics. And when I execute this, and you already saw them in Management Studio, those 2 columns, and here they are. They are the special offer ID column and the modify date column. Okay. So now I'm going to do a query. Simple query, but notice that I have a predicate where D order quantity equals 25. Order quantities does not currently have statistics on it, so simply by executing this, a statistic object will get created on that column. And we don't care about the results. I'm going to refresh. Notice over here in Object Explorer, one of the banes of Object Explorer is it doesn't refresh automatically. How many times does somebody say, why isn't it there? Well, have you refreshed? So we're going to refresh the statistics, and we'll see that another one shows up. We now have 3 automatically created statistics. And when I execute that same query again, you'll see now that order quantity now is included in the list of columns that have automatically created statistics on them. And if I take a look at the histogram here, this is Again, the 004, that's the column number for the order quantity that I just created. So we're going to look at the histogram of that. And notice, in fact, there's 39 rows, so it didn't even go anywhere near the maximum of 200 rows, steps. Okay? So that histogram right now was just created automatically simply because I queried including the order quantity in a predicate. Okay? And that's important to remember. I'll come back to that in a little bit. So we can also update statistics manually. We can say, I want to update the statistics, and when I do that, I can optionally specify full scan or the number of rows or the percentage of rows within the table to scan in the process of calculating the statistics. So in this case, I'm going to just show the statistics on, again, that B column. I can't remember which one that B column was. It looks like it was the modified date column. And notice the updated timestamp. The last time it was updated, was at 7:43 p.m. November 7th, that's today, so it's 7:43. I'm going to now update it with full scan. Oh, wait, let me look at this again. Notice that there's 121,000 rows in it, and when that statistics was created, because it hasn't been updated since the initial creation, there were 110,000, so 90-some percent, or a high percentage, but not all of the rows were sampled in the process of creating the statistics. So I'm going to update the statistics with a full scan. I'm going to say, yes, read every single row in there to create the statistics. We're still limited to the 200 steps. And now when I take a look at the statistics again, notice that it shows current time, and it also shows that the rows sampled is the entire table, because I force it to look at every row in the table. So note here, I'll read it. If you manually update stats, it's recommended to disable auto stats for that statistic object. Let's say that I have a statistic object that I want to manage myself. For whatever reason, I say I want to update the statistics periodically. Do it once a day, once a week, or on some trigger, whatever. If I do that, I want to make sure to turn off the automatic updating of it, because if I update it, I might update with full scan and get really accurate as possible numbers. But if the automatic updating occurs, it's not going to use my full scan. It's going to go back to its internal algorithm, which is something less than full scan, and I don't want that to happen if I'm doing a full scan. So anytime you're going to manage one manually, make sure to turn it off for that column. SP create stats is one more system stored procedure, and it creates column statistics where they don't already exist. So I have yet to see a case where that's valuable. In fact, I'd be interested if any of you know when that's valuable. If you have a brand new database with no statistics and you're going to start hitting it heavy, I can see where you might say, look, at every query that comes in here is going to create statistics as it executes. So why don't you go ahead and create them now? But that's not usually the case. And SP update stats is very similar. It executes update statistics for everything in the database. That can take a while. Okay, what can go wrong? So statistics are cool things, but because of the fact that they're approximate, they're estimated, and they can become stale, things can go wrong. They're not perfect. So we can get a bad sample. Remember that we're not always, by default, sampling everything. We're going through, and there is some algorithm how many rows to sample. And by doing that, we can get some bad statistics. So I'm going to take a look at the statistics of this object that we just created automatically, and we're going to look at it a little bit more. And as we scroll down, notice, first of all, we have 39 rows out of the 200. Now that kind of tells me that it's a small table. There may be 39 rows, or not. If there's more than 39 rows, there's not very many more than that, because why not sample it all with a really small table like that? There's not thousands of rows. Otherwise, we'd have a larger number of steps. And notice that it in fact is an integer. If we look at the table, we can see it's an integer. And we're getting all of the rows. It's very incremental. And notice that there's no range rows because it's an integer. If it's an integer, there's nothing between 1 and 2. And as we scroll down here, remember this statistic. I didn't create this. I didn't do anything special. This was created because I submitted a query, period. As I scroll down here, I get something kind of funny looking. So notice right here, between 24 and 26, there are supposedly over 9,000 rows. Now, I'm suspicious that that's not really true. And since these are integers, that means there's over 9,000 with a value of 25. So the first thing I'm going to do is I'm going to query the table. Let's see how many rows there are really with 25 in there, with a value of 25. And that's what this query does. It just, in between those two. So I ordered them as 23, 24, 25, 26, 27. Notice that there's 17 rows, not 9,000 rows, with a value of 25. So that histogram is bad. And it's bad totally within the way that it normally executes. I just simply queried it, and it created it. I didn't do anything to make it mess up. It did it on its own. So why is that bad? So first of all, I'm going to do a couple of things. I'm going to look at statistics I/O, and if you know anything about queries, you'll probably agree that the I/O, the reading the data out of memory, is the heaviest component of executing a query. There's also the CPU, there's other things, but reading it, that I/O is usually considered the heavy hitter. So I'm going to take a look at how much I/O we have to satisfy a query. And then we're going to also look at the actual execution plan by turning it on. And I'm going to execute this simple query, which is just a simple join header to detail, where the order quantity equals 25, which of course is our one in question. And when I execute this, first of all, the I/O. The important thing, if you're not familiar with I/O, is the logical reads is the most important part of that. That's the number of 8K pages that it has to read out of memory to satisfy this query. So we are, a little over 1,800 pages had to be read to satisfy that query. That query was executed based on what the optimizer was told. There's 9,000 rows. So if we then look at the execution plan, and get rid of that guy. Here's the execution plan. And here's the sales order detail table here. And notice that it says a clustered index scan, which is the same thing as a table scan. It read the entire table looking for that 25. And see if I can highlight. If you highlight over one of those arrows in the actual execution plan, it'll show you two important things. The estimated number of rows and the actual number of rows. And just as we expected, the estimated number of rows is not just over 9,000 because statistic object said there's 9,000 in there like that. And in fact, there was only 17. So I'm going to update the statistics with full scan and see if I can't get my keystrokes to work right. And now I'm going to take a look at the histogram. And as I scroll down it, and I can't scroll down like that, notice that there are no more than big 9,000. There's one of them with 2 or something, but that's pretty minor. So a full scan looks like it fixed the problem. So let's take a look at that query again. And the first one to look at is the logical I/O. It was, 1850 or so before, and now it's just under 1,300. So, 40% or so savings. And when we look at the actual execution plan, first of all, note it looks a little different because it is. And instead of a merge join that we had before, we now have a nested loop, which is the right thing to do here. And for the sales order detail is now the outer in the nested loop, totally different plan because it got more accurate statistics, decided a different way to do it, and in this case, a better way to do it by about 40%. Okay, the second thing that can go wrong is a thing called ascending key, which first of all is a bit of a misnomer. First of all, it doesn't have to be ascending, it can also be descending, and it doesn't have to be a key at all, it can be a column. So what is ascending key? So any of you have identity columns in your tables? Yes. Okay. Identity columns are usually configured to be increasing, right? Do any of you have like a modified date or last modified date column to specify when that row was last touched? Yep. How about a sales table where you have a sales date, which as you put stuff into the database is usually getting later and later, right? You don't typically put in sales for 2 years ago, it's already in there. So those are all values that are increasing. Think about the histogram. Histogram is the lowest value and the highest value as of the time that the histogram was created. So let's say that this is the last modified date column. And I do create statistics right now. Okay, the first row in there was 5 years ago, and I've got one with today's date. And then tomorrow I insert 5 rows. Those 5 rows are going to be outside of the range of that histogram. The histogram, if you saw, in fact, maybe I can bring one up. The histograms start out that the very first row, let's see, there's one. I'll just show this guy. The very first row says how many rows are less than this row and greater than the previous. And of course, the first row, there is no previous, so it's effectively saying how many rows are less than this one? 0. That's the lowest one. And the same is true at the other end, the highest one. So you start inserting these rows outside of the range of the histogram, and then there's a query that says, go get me everything that's on this date out here, outside of the range. The histogram says, I don't have any, but there's a rule that says you can't have 0, so it always returns 1. So the optimizer says, oh, I expect 1 row, and it creates a plan accordingly. But there could be hundreds, there could be thousands of rows outside that range. And that is an ascending key problem. And I believe that that's one of the most prevalent performance killers having to do with statistics, the ascending key. They're all over the place. Identity columns all over the place. Many tables have modified date or some date field that is typically close to today, which is a target for ascending key, or a candidate for ascending key. So, do I have a... Yes, I have. Yes, let me cover this before I get to the demo. I mentioned that it's 0 rows is what is displayed, and so the cardinality estimator can't show 0, so it says 1. That's true up to 2014, and this is one of the main things that was changed. Another main thing that was changed with the cardinality estimator. Cardinality estimator says, you know, I'm going to guess that there are some rows out there because I know that I've had a bunch of rows changed in the table, because remember we saw the number of rows modified count. So it knows how many rows have been changed since the last time the statistics were updated. And the new algorithm says take 30% of that number of rows. So if there are 1,000 rows in there, it's going to estimate 300. And it's an attempt to get a more accurate number of an unknown, because we don't know how many rows there are. There could be 0, but 30 is more common than, yes.
So you're saying that if 1,000 rows have changed, it estimates 30% of them,
300,
300 of those, 30%, to be beyond the range. Mm-hmm. And that number, is there any reason behind that 30%?
I'm sure somebody has a reason for it. These are not precise mathematical things, because you're trying to estimate an unknown. And I will assume that Microsoft has done a lot of study and said, you know, with all the different variety of types of columns and data going into it, 30 seems like a pretty accurate number as best we can do. There'll be cases when there's going to be 0, and there'll be cases when it's 100%.
Or maybe it was done at the bar with our
Or
third
maybe it was
drink,
done-
and they said, let's do 30. Let's go on.
Could be that too. So here I've got a demo. And turn off my actual execution, turn off statistics IO. We don't care about that. And let's take a look at the statistics for this one column. And that one column is the B column. Let's see what that column is. That's the modified date column. And I should look at the very last one. Scroll down. The very last one is, what was that, June 30th of 2014. That's the highest value in the histogram for that column in the table. So I'm going to insert several rows into there, and I've got to insert into the header and then the detail, because, you know, foreign key relationships. And boy, that runs fast when I turn off actual execution. Now, I'm going to execute this just to make sure that if I've hit the threshold, it'll update it, but it hasn't. It didn't. Now, when I look at it, you'll see that we are still at June 30th. I just inserted a bunch of rows. We'll see in a moment how many rows I inserted, but I inserted all those rows greater than that June 30th value. And the last time the statistics were updated, we'll look at another stats here, is that they were updated at 8:33. What time is it? 8:52. Okay, and also note our modification counter. That tells us right there that since the statistics were last created or updated, 4,000 rows have changed in that table. But that's not enough based on the algorithm to update the statistics. So I've got some stale statistics. And as it turns out, every one of those 4,000 rows is outside of that histogram range. They're all ascending keys. So now that I have inaccurate statistics, I want to prove to you, here's a query that just shows how many rows are there greater than that largest value in the histogram. And there's my 4,000. Every one of them is greater than that value. So to show you the two different behaviors, one prior to SQL Server 2014 and one 2014 and newer, I'm going to first of all put it into 2012 compatibility mode, so it'll use the old cardinality estimator. And now I'm going to look at actual execution plan. And when I go over the sales order detail and highlight it, as I said, it can't estimate 0, and this is pre-2014, so it's going to estimate 1, and in fact, there were 4,000. And so it chose to do a nested loop with that detail table being the outer table. Remember, it's different depending on which table is which. It's a totally different nested loop. So now let's put it into 2016 compatibility mode, which is the same as 2014, when they changed the cardinality estimator. And I'll run the same query again and take a look at the execution plan. And this time, first of all, notice that the sales order detail is now the inner table in the nested loop. And when I hover over that line, notice that I get, again, the actual number of rows is still 4,000, but the estimated number of rows is 1,200. It's still not super accurate, but it's a lot better than 1, and it came up with a better plan. It is still an issue. And in this case, it's a decent plan, but in some cases it could be a terrible plan. It's still not accurate. This is a perfect case where you might want to manage the statistics yourself. I have a column. I know that I'm putting in new dates in that or identity column. You might want to manually trigger an update of the statistics. I've got one application where it's an ETL where nightly we run a process and load the table. We load the table. When we're all done loading the table, I update the statistics on a couple of columns. Last modified timestamp, identity column, anything that could be an ascending key. So I know that after they change, they're going to be as current as possible. And remember also, if you do that, make sure to turn off the automatic updating of the statistics because they could become less accurate. Okay, so now I'm going to update the statistics with full scan. I'm going to take a look at them to see what the last one is. And sure enough, I've got 2,000 rows with each of these two values. And now when I do that, execute the query again, there's my sales order detail. And in fact, this again, even though I did a full scan update, it's not exact, but that's awful close. Now that's close enough where I would never worry about it. So now that you know what they are, how do you know how to find them? I have created and I called it SP underscore because I put it into master, and it is a system stored procedure. SP find statistics outliers. That stored procedure will query your database. You can specify a schema or a table or the whole database, and it'll look at the statistics and it'll look at the values in every column and look for any cases where there's values in the column outside of the range of the histogram. And it'll report, it puts it all in a table, and then you can look at the table and say, okay, here's some candidates for ascending key problems. Do not run that in production. It can take a long time to run with a lot of data. I can run it on AdventureWorks 2014 because that's a relatively small database. If you execute it without any arguments, it will return the syntax, so you don't have to remember what to pass into it. And then when I execute it, in this case, I'm going to give it I'm just going to say what database to do. I'm not going to specify schema or table, so it's going to do the entire database. And it takes a little bit of time. Within the header of the stored procedure is the syntax to create the table that is populated with the results of this. So it just finished. And now when I take a look at that table, you'll see that I have a list of tables and columns that are ascending key candidates. And as you notice, we've got some other with the production, the header tables. I'm sorry, that's not the header. Here's the header tables. Remember, I updated the statistics on the detail table, so that doesn't show up here. But I didn't do the header table, and it has all those rows outside the range. So if I got this report back, or if I ran this and this is what I got, I would start going out and saying, do we ever query that table for that on that column? And if so, these are ones that I probably want to or might want to manage manually. Summary. They're very important. And where do I say it? Oh, they're great but not perfect. Important to know that they're estimates. Ascending key issues, I honestly believe that's a major problem that a lot of people don't even know that they have, and make sure to override default. Any other questions?
Okay, here's my really important question.
Yes.
When you are forced, well, forced is not the right way of saying it. When you happen to run SP update stats in production to fix a performance issue, obviously there's better ways to handle this. In some cases, not that I personally would do this.
Never.
Never. It alleviates the problem.
Sure.
So obviously there's some indication that
Let
statistics.
me
do need
rephrase
managed.
that.
Yep,
Right now, it alleviates the symptoms.
that's a better way of saying it. Yes. There must be a better approach than just that knee-jerk reaction of hitting update stats.
Yes and no. It's a wonderful answer. It depends. If people are yelling and screaming they can't get at their data because things are so slow, somebody's blocking somebody else, then maybe that knee-jerk reaction is the best short-term solution. The next step would be to try and duplicate it in another environment and find out exactly where the problem or problems are and fix them permanently by manually managing the statistics. Updating them all automatically or without consideration, it should only be done if people are screaming but sometimes that happens.
Yeah, and that's normally the only time that we hypothetically run this.
Hypothetically, yeah.
But yeah,
But you mask other problems too.
There's quite a bit of users in this circumstance. Hundreds of users are using this at the same time. But knowing all that you've shown here today, it looks like we have a whole new level we can dig into to figure out maybe be causing this. And the whole idea of the problem you described of having new records. In this case, this is purchasing. New records that are ascending order.
Purchase date or something, yeah.
Thousands are being added all the time. And I can see where suddenly, and it's very current now kind of thing, as soon as they add this, and there are millions of records in there already, it could easily get out of sync with what you just talked about. So it makes me wonder right now, there's a smoking gun.
To clarify on your solution, Vern, so it's this hypothetical situation where we're updating all the stats. It sounds like it is not an issue of all the stats, but it may even just be 2 or 3 of the stats that actually need to be updated,
right?
Because they're the pain point.
Almost, yeah, that's probably the case. And the problem with updating them all is that you might fix the 1 or 2 real problems that are screaming right now, but you might have 10 other ones that are really slowing things down but aren't super serious, and by updating you just mask those. And so tomorrow when you're troubleshooting and looking for other problems, they're gone. You don't see the issue with those. So it's not without a price, but if you have screaming clients, sometimes there's not another reasonable choice.
Thank you. That was helpful.
Oh shit, I was on mute the whole time.